This is Chapter 11, Section 1, Sequences and Summation Notation. Hopefully some of this is review. First we have the general description or definition of what a sequence is. It's a number that's really a list of numbers. They go sometimes in some sort of order. Sometimes you can't come up with a formula though. Finding the first 5 terms and then the 100th term of the sequence of the formula. So if we plug the first term in, 8 times 1 minus 2, we get 6. If we plug the second term in, 8 times 2 minus 2, so we notice that it's going up by 8. Oh, so the third term will be 22, the fourth term 30, the fifth term is 38, the 100th term is 798. For the next sequence, to plug in 1 cubed minus 4 is negative 3. Second term is 4. The third term, this is not like a pattern, you notice. One way to figure this out is you can use your calculator. Go to y equals, clear this out, and I'm going to put in x to the third minus 4. Go to my table. Oh, let me change my table. There's my first 3 terms. Negative 3. Right there. There's my first 5 terms. Oops. C to the fourth. Fourth term is 60. Fifth term is 121. And then the 100th term, 99,996. So you could do that for the rest of these. There's also the sequence place in your calculator, which is under this one? No, this one. 5? Yeah. If you go to vars and then number 5, which is statistics, and we go over, no, it's definitely not under that one. Which one is it under? Why do I not remember this? It's not under stats. Oh. Ah, there we go. Above list. It's above stat. And there's one above stat. It's under that. If you go over to the opposite, you go down to number 5, which is sequence. Let me get rid of this box. This might come up. It's going to look different if you're on an 83. But the first thing is to put in your actual function. So I'm going to put in parentheses -1 to the x. Uh-oh. Divided by 3 to the x. Our variable is an x. We want the first term all the way to the 5th term, and we're going up by 1s. Hit paste. And then it'll show up on your screen. Hit enter. If you don't like those numbers, you should change it to fractions for you. There we go. So the first term was -1/3, second term a 9th, third term -1/27, fourth term 1 over 81. Fifth term is negative 1 over 243. And the 100th term, 1 over 3 to the 100th because it's really big. And you can do D on your own. In all sequences, formulas such as the list of prime numbers, there's no formula for that. Finding the nth term whose first several terms are given, this is sometimes a little difficult. You got to figure out some type of pattern. Well, these are all even and they alternate signs. If they alternate signs, it's got to be a negative 1 in there. And they are all going doubling, so times 2 to the n. That works. N would be our terms, so we put in a 1. Still get negative 2, put a 2 in. Then we get a positive 4. For this next one, it is going up. That's 3 to the first. Oh, no. Oh, 3 to the first, add 2. This one's 3 squared, add 2. This is 3 cubed, add 2. So our formula would be 3 to the n minus 1, because we got to get that beginning 3 in there, and then add 2. A sequence defined by finding some or all of its terms, it's called recursive. Recursive is when you just write a sequence using the preceding term. Like this is a recursive sequence right here, where they use the 2 preceding terms to get to the one that you want. So if I know the first and the second is 3 and 8, well, 3 is the first one, 8's the next one. To get to the next one, we're just adding the 2 previous ones. So then we have 11. And then 8 plus 11 is 19. And so on with the pattern. We get 30, 49, 79, 128. And we have this recursive one, but they just changed our first 2 terms to be 1 and 1. 2 is the next one, because 1 plus 1 is 2. And 3, 5, 8, 13, 21. This is a special sequence. It's called the Fibonacci sequence right there. Fibonacci was a famous Italian mathematician, which you should know about because I'm sure somebody probably did a report on him. He actually didn't come up with the sequence. He is attributed to it as discovering more about it, but I think it was a Chinese or somebody came up with it. The Fibonacci sequence occurs in nature. If you look, you could split a tree here along its branches and it creates the Fibonacci numbers. Here is the seashell. And if you draw the seashell into the coils, you can do Fibonacci numbers throughout the seashell, which Fibonacci numbers also have to do with the golden ratio, in case you didn't know that. Here, partial sums is when you add up specific terms, and it'll be specify how far to go on a partial sum. So if we want to find the first 4 partial sums and the nth partial sum given by this sequence, well, first we need to know the terms. So the first term is 1, second term is 3, third term is 5, fourth term is 7. So if I want the first 4 partial sums, the first sum is the first term. The second sum would be the 1 plus the 3, giving us 4. The third sum is the 1 plus the 3 plus the 5, giving us 9. And the fourth sum, 1 plus 3 plus 5 plus 7, getting us 16. And if you look, these numbers, they are perfect squares. So the nth partial sum is n squared. The fourth sum was 16, third sum was 9, second sum 4, and so on. So we can do the same thing again. The first 4 terms. The first term is a 6th, the second term is a 12th, the third term is a 20th, and the fourth term is a 30th. So the first sum is just the first one. The second sum is the 6th plus the 12th, giving us a 4th. The third sum is a 6th, 12th, and 20th, giving us 3/10. The fourth sum, 6 12th, 20th, and 30th, giving us a third. And we'll just not worry about the nth partial sum for this one. Sigma notation is the next thing. That's when you use the E. The bottom number is where you begin, the top number is where you end. You add up how many terms they're asking about. So for this first one, we'd be adding 5 plus 6 plus 7 plus 8 plus 9, giving us 35. This one I'll show you how to do in the calculator. So if we go back to our calculator, second stat, this time go over to math where there's a sum. Second stat, go over to ops, the sequence. We're going to clear that out. This one is just x. Our variable is x. This one we're starting at 2 to 9. We're going up by ones, hit paste, hit enter again, and the answer is 44. This one is just, sorry about that. 2 to 7 is 6 spots, so you're doing 6 2s, which is 12. And this last one ends up being 13 over 12. Last thing, writing sigma notation. Well, if you notice, the 3 to the 9 is what's changing. They're all to the 4th. So our function is x to the 4th. Since I'm using variable x, I'm telling x is going to start at 3, and it's going to go to 9. And even look, this is the inside of the square root is changing. So I'm going to use x as my variable again. My first one is a 2. We're going up to 50. And the last part is just properties of sigma notation. You could separate them by addition, subtraction, even with a scalar. You could just do those sigma notations individually and then combine them at the end. That is the